Hello everyone, welcome back to my channel. I am Vamshik Shetty, pursuing third year B in Shivinteshwara College of Engineering, Bangalore. Today in this video, we are going to discuss about the one of the major topic in the renewable energy and the power plant, that is the layout of the Hydel power plants. Now let us discuss about the what is Hydel power plants and the what are the structures of the Hydel power plants and what are the components used for the Hydel power plants. Yeah, first let us discuss about the components which we are going to use in the Hydel power plants. The main components of a storage type Hydel power plants are as follows. The first is the catchment area, the second is the reservoir, and the third is the dam, the penstock, forebay, powerhouse, draft tube, spillway, and the surge tank. These are the major nine components which we are going to use it in the storage type of Hydel power plants. Now let us discuss about the each and every components which we are going to use in the Hydel power plants. Now first let us discuss about the catchment area. Before going to the catchment area, now let us briefly go with the components where we are going to construct the which we are going to use for the construction of the idle power plant. The first is the catchment area, as we can see, and the second, as we can see in the catchment area, and then we are the reservoir, and after the reservoir which comes the dam, and then the valve which we are going to use for the inlet and the outlet of the water, and the penstock for the generation of the water to the turbine, and the inlet valve. This is the outlet valve on the inlet valve, and the three-phase supply which is used for used in the turbine with respect to the alternator, and then we are going for the draft tube and the tail race which will generate the uh, electricity. Now let us discuss about the catchment area. This is the first component where the what is catchment area. Now first let us discuss about the catchment area, the area where water is collected and directed into the reservoir. The size and the features of the area affect how much water is available, influencing the plant's performance. Good management of this area is essential for keeping water clean and ensuring a steady supply for power production. Proper care of this area helps us to prevent soil loss, build up of sediments, and the environmental harm, and making the project more sustainable. This is about the catchment area. Now let us discuss about the next component, that is reservoir. The reservoir stores the large amounts of water for consistent electricity generation. It collects water from rainy seasons and releases it when needed for the power production. What is controlled through the turbines? Water is controlled through the turbines to convert potential energy into electricity. The reservoir also supports the flood control, irrigations, and the recreational activities. So this is about the reservoir. Now let us discuss about the next component, that is dam. This is the main component which we are going to use for the hydropower plant, where the dam blocks a river to create a reservoir, storing water for electricity generation. It regulates water flow to ensure a steady supply to turbines via penstocks, controls water release for consistent electricity production, and manages flood risk. It also increases the reservoir capacity and working ahead for the efficient power plant operation. Despite environmental and the social impacts, dams are essential for large-scale hydroelectric power. So this is mainly about the dam. And next, we go for the next component, that is the penstock. It is one of the main component used for the hydroelectric power plant. It is a mainly a pipe between the surge tank and the prime mover, is known as penstock. It is structurally similar to the other pipes, but reinforced with the withstand high pressures from water hammer during the load fluctuations. Usually made up of seed. Usually the penstocks are made up of steel. Penstocks have head gates at the inlet for the maintenance, and in cold weathers, burying penstocks prevents ice formation and reduces the need for the expansion joints. Penstocks control water flow and the pressure to optimize the turbine speed and the energy generation efficiency. This is about the penstock. Now let us move on to the next component, that is the forebay. The forebay regulates water flow to the turbines located upstream of the powerhouse. It stabilizes the water flow and the pressure before entering the penstocks downhill to the turbines. Maintaining the steady flow optimizes electricity generation efficiency. Also, forebay acts as the buffer during the water level fluctuations, enhancing the plant reliability. Also forebay also used in the critical in managing the hydropower plants operations for the effective renewable energy generations. This is about the forebay. Now let us discuss about the other component, that is the powerhouse. The powerhouse plays a crucial role in generation of the electricity from the hydropower plant. The powerhouse serves as a critical hub for the electricity generation. It acts as the houses for the turbines and the generators that convert water's kinetic energy into the electrical energy. It is located at the base of the dam or alongside the penstocks. It accommodates the large turbines turned by the rushing water. Also, it controls the system managed water flow and the electricity output to meet demand, ensuring efficient energy conversion. So, this is about the powerhouse. Now let us discuss about the another component used in the hydropower plant, that is the draft tube. The draft tube connects a turbine's outlet to the tail race below. It recovers the kinetic energy from existing water, converting it into pressure energy, and it increases the turbine's efficiency by reducing the outlet pressure for better energy extraction, and also optimizes the flow conditions to minimize the energy losses and enhance the turbine performance. And it is also essential for sustainable and the efficient electricity generation in the hydropower plants. So this is about the draft tube. And now let us discuss about the another component, that is the spillway. A spillway manages excess water flow to prevent dam overtopping during high inflow or flooding. It is located at or near the dam. It redirects the surplus water through channels or gates downstreams. It also maintains the dam integrity and ensures the downstream safety by preventing flooding. It is designed in various based on the reservoir size, water flow rates, and the environmental factors. In modern, it is designed as the in the it is designed in the modern design maximize the safety and the efficiency, crucial for the hydropower plant and the hydropower plant resilience. So this is about the spillway. Now let us discuss about the last component which is used in the hydropower plant, that is the surge tank. A surge tank prevents water level fluctuations from affecting penstocks. It is not necessary for short distances between the reservoir and the powerhouse, but crucial for high head turbines. And it is protective device connected to the penstock, and it also stabilizes the velocity and the pressure to guard against the water hammer and vacuum effects. It is critical for maintaining the penstock integrity and hydropower plant efficiency. So these are the main components which is used in the layout of the hydropower plant. So yeah, that's it for this video. Thank you. For more videos, please like, share, and subscribe the channel. Thank you.